Very good evening to one and all. Last class, we concluded our discussion on message authentication codes, what do you mean by MAC, and how the keys can be appended in MAC. Like, that is, you can able to append in the prefix, postfix, or you can able to combine. Now we see certain methods of message authentication codes. One of them is called nested MAC. Okay. That is, here nested MAC, what they are doing, since they're going to perform the hashing, but in two steps, or we can able to say that double hashing is going to be done. So here you can able to see you'll be having a message here, and here we are having a postfix of a key, that is a secret key. Then we are hashing. So once we are hashing a key plus message, you'll be getting a MAC. What they're doing, since again they're appending with the same copy of key, and this is the hashing in first step. Okay. In second step, they're going with the second round of hashing to get a MAC. Okay, this is called nested MAC, and in nested MAC there are different variants here. One of them is called hashed MAC, shortly called as HMAC. Actually, this nested MAC is nothing but a prototype. How two hashings are going to be done in the following two steps. Okay, so this hashed MAC is one of the famous method under nested MAC. Okay, under a standard called FIPS 198. Okay, we'll see how it works. We'll see here exactly, and these green blocks are nothing but your messages here, right? I have the message here, and here the message is going to be divided into B number of bits. So I hope everyone know how they are going to divide. Suppose if we can't able to have the entire length to be multiple of B bits, then we'll be going with the padding, right? After padding, it should come to a multiple of B number of bits. Then only I can able to equally divide the multiple blocks with B number of bits. And the padding will be done in the same way. That is, the first bit will be 1 and followed with rest of number of zeros. Okay, this is how we will be making our message ready for getting the MAC. And here, how the keys are going to be there. So here the simple key is nothing but B bits of zeros. Whatever the size of B you are choosing, that many zeros. For example, if you are choosing B to be 5, each block will be having 5 bits, means here I will be having 5 zeros. That's all. That is the key we are going to use here. But we are not going to directly append the key here. So for that, I am going to XOR. This is the XOR operation. That is, I am going to XOR the padded B bits. That is simply nothing but the B number of zeros with the value called input pad. So this input pad is nothing but the value 36 in terms of XOR value. Okay, this is actually repeated 8 times. This is repeated 8 times. Okay, and this size will be going to be XORed with the padded B bits, and the final value is alone is going to be postfixed with the message. Right. And if you perform hashing for this entire thing, this is the first hash. You can use any hashing algorithm, whether you can go with the MD4 or SHA, that is based on the scratch, or you can go with the Whirlpool kind of hashing also. So this will give me some n number of bits. Okay, the one condition of choosing this B value is nothing but your n should be always lesser than B. So you have to choose your value of B in such a way that it should be greater than n, because you can't able to change the n, because based on the hashing algorithm you are going to choose the value of n is going to be fixed. So but you can able to vary the size of B accordingly. You can able to choose the value of B in such a way that it should be greater than the value of n. So the ultimate output after first hashing is called as intermediate HMAC. Okay, but it is, since it is lesser than n, I'm going to still pad again bits in order to make it as a B number of bits, and I'll keep that B. This is nothing but your HMAC, or sorry, intermediate HMAC plus padded bits. Okay, will be B number of bits. Again, I'm using same number of zeros. I'm taking the same thing, but this time I'm going to XOR with the output pad. So I'll be getting a different value of B bits, and here the 5C is repeated 8 times again. So here we have one set of B number of bits, and here we'll be having different set of B number of bits. Okay, now this entire thing is again going to be hashed. And one more thing, here you can use the same hashing algorithm, or you can go for different algorithm also, provided the output should be of same n number of bits. Okay, and the final output will be taken as a HMAC value. Is it clear, guys, how this HMAC works on? If it is clear, kindly raise your hand. If you have any doubts, you can ask me now.
Excuse me, sir.
Yes, Kashish.
So this is basically hashing twice.
Yes. Actually, this is nothing but the one version of nested MAC. Here, in nested MAC, they said key will be added post which one hashing, again key will be added, then again hashing. This is one way, like how we had product cipher is a block cipher. One of the product cipher is AES algorithm, one of the product cipher is DES algorithm. Same way. Here, they
Okay, sir.
hashing twice.
Okay, sir. And sir, iPad and OPAD values are same, like
Yes.
they're constant.
Yes.
Like they'll be always 3636 and 5C.
Yes. Actually speaking, if you want to be more specific, this B bits will be always 0, and this 36 will also be fixed, and 5C also fixed. This is actually output pad. This is input pad.
Okay, sir.
Don't have any more doubts? If it is clear, raise your hand. If you have any more doubts, you're most welcome to ask. Okay, fine. So whatever I just explained, it's again there in the steps in these slides which I have given here, right? So you can also go through, you'll get a clear picture again. Next, another version is called CMAC. This is other way of making nested MAC. Okay, so how this one works, I'll just explain in this block itself. Again here, instead of hashing algorithm, here they specifically go with some encryption algorithm. That is, they're making help of my cryptographic techniques. Okay, crypto. Fine. So here they are making with n number of blocks with the fixed size. So accordingly, the padding will be done, and every stuff is done here. Now the key K is used here, which will be given as an input as a key for all the encryption iterations, and the message block will be given as an input for all the plain text. Here the ciphertext which is going to be produced here after first round is going to be XORed with the second. For assume this is P1, this is C1. C1 is going to be XORed with the second plain text of this message block, this message M2, right? And this will be given to the input as my P2. Actually, sorry, this should be actually M2. So this will be XORed. It will get to give me as input for my second iteration's plain text, and this is repeated until the last block is processed. And you can able to see this value of K is coming for all the keys. Okay, except the last place. Okay, here you'll be getting like C n minus 1, that is before blocks 1, and this is mn. And here I'm going to introduce a new parameter called small letter k, which is going to be XORed along with this one. Okay, so what is this small letter k? As per speaking, this is actually the secret node. This is the key required for this encryption algorithm. Okay, how we had like here, this gray part, some secret value. This gray part is nothing but a secret value created from this key. Okay, same way here, this is a unique part k, the gray part how we had in the previous thing. So how this is going to be created, in sense here they making use of the same key which is used for this encryption algorithms, and the same algorithm is utilized here. Okay, in place of plain text, they are giving with me whatever the size you have chosen here. For example, if you chosen m bits, here the same m number of 0 bits are used, and they are encrypted, and the ciphertext is going to be produced. And here they are multiplying with the conventional polynomial arithmetic multiplication. Either they will go with x or a square of multiplication. Okay, how they will choose when I should multiply with x or when I should multiply with x square? It is depending upon the last block of your message. Suppose if your last block of a message has a padding bit, that is you have made some padding. If padding exists, one second. First I'll go with if there is no padding. Simply the entire thing is able to fit within the block size. No padding means then I will be multiplying with x. If there is padding, then the multiplication will be taken place in terms of x square. Right. This is a polynomial arithmetic, and the final output what you are going to get is nothing but the k, and this k is substituted here. Okay, and this encryption algorithm will produce me bits which is greater than value of n. For example, this is the output you are going to get. This will be always greater than value of n, and I'll be choosing the leftmost n number of bits alone. Okay, as my output of my CMAC. Is it clear? If you want me to repeat anywhere, I'm ready to repeat it. Fine. Okay, whatever I just said, it's here. So with this, we are concluding our module 5. So in module 5, we discussed about message integrity. Okay, and we had a brief discussion about how a hashing function is designed and what are the requirements, other things. And we discussed 3 hashing algorithms. Okay, with this, we completed our hashing part. Then we entered into MAC. What is MAC and what is the requirement we just saw. And we just saw the 2 famous MAC techniques going to be which are in use, still in use, right? So with this, I'm concluding our module 5. So anyone have any doubt in this module 5 for any part, I'm ready to discuss. If everything is fine, just raise your hand. Actually speaking, we are going ahead of the schedule, so nothing to worry. So the last time before FAT, we'll be having ample time to revise all the tough topics you people faced in AES, DES, other things. So don't worry. So if anyone have any issues with any of the module, just note it down now itself. With respect to 5th module, if you have any doubts, you can ask me now itself. If everything is fine, then okay. So once again, we'll just have a few introduction about module 6 and we'll wrap up today's session. Fine. Or okay, how many of you want to wrap up now itself so that we'll have fresh start for module 6, or we have like 10 to 15 minutes? Is it okay? No response for this also.
Anything works, sir.
Okay, we'll have few more minutes, right? Yes, Kashish, you are saying?
Yes, sir. Anything is fine.
Yeah. Second.
Yes, sir.
Just a few introduction, that's all. Is it clear? I mean, the visibility is fine? Because
Yes,
being
yes.
in the evening, mostly I won't discuss much technical, just a few introduction and we'll wrap up. Okay, fine. Because already you people would have been exhausted from morning sessions. Okay. Okay, mutual trust is a name given for module 6. So whenever I say mutual trust, you have to trust me and I have to trust you. Right. So in this module, what we are going to discuss in this is nothing but applications of whatever we just studied before this module. That is, we discussed about data confidentiality and data integrity. To maintain data confidentiality, we saw cryptographic techniques, and for integrity, we just saw hashing and MAC. So what are the applications which have been used using these 2 techniques? Like the most important thing is nothing but digital signature. Okay. Then here also we are going to have a detailed discussion of key management and how the distribution is going to work, and certain user authentication protocols. Okay. So we'll start our detailed discussion on digital signatures, then we'll move on to other stuffs. Right. So today we'll just give a few introduction about digital signatures, because during this pandemic situations, most of the people are using digital signatures. Right. For even if you start from educational domain to all the IT industries to all the transactions everywhere, digital signatures nowadays started playing a huge role. Okay. So in this we'll see basic comparison of a digital signature with a physical signature, what we used to do in our documents. Then a few digital signature process. Then what are the attacks which can be done on digital signature? And here we have a detailed discussion of few mostly used digital signature schemes. Right. So start off with if you compare with your digital signature, the conventional signature, what are the major differences? I hope everyone knows what is a signature, because most of the people except celebrities, they use everyone uses the same signature everywhere, because celebrities they use the signature, different signature for autograph and other stuff, and they use for legitimate document signatures, everything they go with their another signature. But apart from that, most of the common people will use the same signature, right? At least from your starting from your higher secondary period, most of the people will have same signature. Some people would have changed, but after you are entering into professional life, obviously you'll be having the same signature till the end. Right? So what are the differences? Because everyone nowadays saying digital signature is also valid with respect to conventional signature. If you see the difference between then, if you take a conventional signature, it will be present on the document. We will be signing any part on the document. Whereas here, we will be signing digitally, but the signature will be in a separate document and the document will be separate. I mean, in the sense, message will be separate and your signature will be separate. It's like it's a basic application of a hashing algorithm. You'll be having a message and digest value separate, same way. Right? Then verification method. How will you be verifying whether the digital signature is a legitimate one, it's a valid one or not? If you go with conventional signature, we'll be having an original document with us, or some person will be having an original document and will be comparing the signature and he'll be verifying the thing. Whereas in digital signature, okay, the recipient will receive message and signature separately. Right. Both of them will be received, and here we will be using a separate technique called verification technique. We'll be coming across those things. Okay, how we have encryption and decryption, same way we have verification technique which will be applied on the combinations of both the signature and the message. Okay, we'll be using both message and signature, and we'll be applying this verification technique to verify the authenticity. Okay, and the relationship in the sense here, as I said, the conventional signature is a one-to-many relationship. So whatever the documents that you're going to sign, for example, you are signing a checkbook, you'll be using a signature. If you are buying a house or car, at that time also you'll be making same signature, whatever the documents may be. Whereas in digital signature, it is a one-to-one relationship. That is, if you are person X, okay, and you are sending a document D1, D1 will be related with the signature S1. You having second document D2, it will be related to a second signature S2, and so on. So each and every document will have own signature, okay, which will be unique for that particular person, but signature will be keep on varying. So it is a one-to-one relationship. And duplicity, so if you take a conventional signature nowadays, there are well equipped and trained people are there. We should make exact replica of our conventional signature nowadays. But this is not at all possible in digital signature. You will see how it works in the upcoming slides. Right. This is a basic process, and as I said, how the digital signature process will work on. We'll be having a message here, and here we are using a separate algorithm called signing algorithm. Okay. So once the signing algorithm is done, I'll be getting a signature as output. I'll be sending the message and signature altogether to the receiver. Receiver will apply a verifying algorithm over this message and signature. And once it is, message is passing this verification algorithm, then this message will be accepted. Otherwise, it will be rejected. So this is the basic process of digital signature going to happen. Is it clear? Hope people have some rough idea what is a digital signature, how it is different from our conventional way. If it is clear, kindly raise your hand. Okay. So I think, okay, with this I will wrap up today's session, guys. Okay. So next class onwards, we'll move into deep into how this signature process works on and other stuffs.